My name, my name is Vishnu Chaudhary. Roll number IT 2K24 and enrollment number DE 2402045. That was my lab assignment one. Let's go to the 1.1 bisection method. Assumption is all that their function fx is continuous in interval inter and error tolerance is predefined and maximum number of iteration is fixed. A bisection method algorithm start input value a b and tolerance e, check whether fa fb, and now we have this algorithm input values a b and tolerance e, check whether fa into fb greater than equal to 0. Compute midpoint c is equals to a plus b by 2. If c is equals to 0, then z is the root. If a that was time complexity O login, space complexity O1, geometric representation was that. Now let's move to the 1.2 regular false method. Um, Assumption was function is continuous, initial interval continued, and error tolerance is predefined. Now move to the algorithm. Start input ABE, compute, and fifth step, sixth else set x was to x. Repeat until I required accuracy such different root, time complexity on, space complexity o1, geometric representation. Now second method and move to the 1.4 Newton method. That was a function is differentiable. Initial case is close to the actual root. Derivative is not zero. Right check algorithm and input initial get sets not a tolerance compute display root time complexity or login space complexity. Now we have check fixed point iteration method. Equation can be written in form of x is equals to zx. Initial approximation is available. Function converges is in. Now check the algorithm. Start input initial value x naught and tolerance e. Compute xn plus 1 is equals to gxn. Repeat until xn plus 1 minus xn. Display root stop time complexity on space complexity o1. The root of the intersection point of y is equals to gx, y is equals to x. Algorithm for applying interpolation. Now let's move to Lagrange interpolation. Assumption was that all you can take it by our own. And now formula where LIX algorithm start input number of data points and input value of xi yi input interpolation. Now with that there's the time complexity on square space complexity o1 and move to the Hermite interpolation method. Assumption function value and derivative values are known. Interpolation polynomial is continuous theory. Now I'll check algorithm start input number of data and input xi yi date. Now check time complexity that because that was the uh, whole math because that was the algorithm. Now check time complexity on square space complexity on square. Now 2.3 divide difference table. Data points are distinct, function values are available, polynomial interpolation exists. Theory defined difference when constructor interpolation polynomial recursively. Now that was start input number of input xi y construct divide difference table compute it form Newton divide evaluate polynomial at required value display result stop. Now check the 2.4 difference table. Data points are equally spaced, function value are known, finite difference exists. Now check to the time complexity on square space complexity on square. Now check Newton interpolation formula using difference assumption. Points are equally spaced. Different tables can be formed from. Now check algorithm for that. Start input number of data points and input x and y values. Construct difference table. Compute value of p. Apply Newton interpolation formula. Compute interpolated value. Display result. Stop and complexity o n square. Space complexity. Now check to the. Now move to the fourth way. method based on finite difference. Data points are equally spaced, function are known. Step S size is small. Now that there is three formula, we can work on it and compute it in algorithm start. And that was the algorithm. You can check, I highlighted it there. Now time complexity O and space complexity O1. Geometry representation, the derivative approximate the slope of the tangent to the curve using nearby points. Newton codes formula assumption we have there. You can check it by I've highlighted it. You can check it. Now the theory part was Newton code formula. Numerical integration method used to approximate the area under curve by fitting polynomial to data points. That they have three. You can check it. I have also highlighted. Now move to the algorithm for that. We have algorithm start, input, lower limit, a and b, compute step size. We have uh, compute step size and compute function value at required points, apply Newton codes formula and display result. Time complexity O and space complexity O1. Now Gauss quadrature formula we have. Gauss function is continuous, integration interval is finite pi, and that was the algorithm. We can highlighted it by that. Now space time complexity is O and space complexity O1. Geometric representation area under the curve is approximated. Now let's move to the 5.2 algorithm for iterative method. Jacobi iteration method. Coefficient matrix is diagonally dominated. Now that there is uh, algorithm start, input coefficient matrix A and B, input initial input rearrange equation for iterative form, compute new values, display solution in IT sport. Now we have cost hidden method. Coefficient matrix is diagonally dominated. Initial approximation are available. Iterative process converges. Now formula for that. Now we make algorithm. That was the algorithm for that. Now time complexity O(n) square. Time space complexity O(n). Geometric interpretation was that the iterative approximation gradually the common. We have approximation now 6.2 approximation using orthogonal value. That was the assumption. We take it first. You can check it. Now we have general formula for that approximation. Now we make algorithm by that input function value of data and select orthogonal value. Display approximation. Time complexity one square space complexity. Now move to the Euler method, difference equation that and the algorithm for that Euler method. Time complexity O(n) and space complexity O(1). That was the geometrical representation. And move to the 7.2 the Runge-Gupta method. Uh, there they have four formulas K1, K2, K3, K4 and yn plus 1. Now algorithm have a start input, input number of iteration, compute K1, K2, K3, K4, compute yn plus 1, update x value, repeat until required. Now stop it. Now on space. Now we have completed the lab assignment 1, Viva, lab assignment 1. Thank you everyone for watching my video. I made this video under the guidance of Mr. SHALIGRAM Prajapati sir. Thank you. Please like, subscribe and comment.